This is part 11 of the Craftsman 6-inch joiner rebuild series. If you haven't seen part 10, click the link at the top of the screen. In this video, we will be cleaning the panels and wiring or rewiring the motor and some of the components for the motor. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. For cleaning the panels, I like using this Meguiar's plastic cleaner polish. I think that's what it's called. You can get it at your various auto parts stores, but frankly turned me on to this stuff and it works great. So basically I'm applying this to each one of these panels and I'm going to let it sit for about 10 to 15 minutes. And then we're going to come back and we're going to buff it off. This does a really good job of cleaning up these panels. I use it on the drill presses all the time, on the panels for those. So we wait about 15 minutes and then we come back and we just buff it off. I'm just using a microfiber towel to do this. And we'll speed up the video here. So this panel gave me the most trouble. This is the depth setting panel, and there is some glue or stain or something on there that this stuff is, or the cleaner polish is not pulling off. So went ahead and broke out my Fordham / Dremel, and I've just got a small brass wheel on there, wire wheel, and we're just going to wire wheel that stuff. And that pulled it off of there, no problem. So I also noticed that it's got a dent in it, so we're going to go ahead and bang that out. I'm just using a brass punch. We're just banging it out from the inside. Doesn't have to be perfect, just want to get it a little better than it looks right now. So, good enough. And then continue hitting that with that wire brush. Now, all those fractions there are recessed, but I don't want to have to take the time to get in there and repaint them and stuff, so I'm going to leave that area kind of untouched. And this is the protractor for the fence. This is the Craftsman logo panel and the model number panel. There's some more glue or something on there. And I think I messed it up a little bit with that wire wheel. I kind of cut into the black there a little, but no big deal. And then this is the motor data panel. So if these are really bad, a lot of times I'll just have Matte Blast reproduce one for me, but this one isn't too bad. It's still pretty legible, so I decided to just keep it. All right, so for that depth gauge panel, I'm going to go ahead and polish it up with the Mother's Mag and aluminum polish. So we'll just apply that and let it sit for about 10 minutes, 10 to 15 minutes, and then we're going to buff it off of there. So here I'm just using cotton buffing wheels on my Fordham. You can see how that stuff turns really black. Then we'll switch out that wheel. And then you can see how shiny that came out. Almost looks chrome, which is what we were shooting for there. Not bad. And we'll just remove the rest of that residue. Yeah, I'm happy with that. All right, so we forgot to do these when we were doing the others. So what you've got is the thermal protection panel off of the motor, and then the on-off plate for the motor switch. And again, we're using that Meguiar's Cleaner Polish Wax, whatever it's called. While that's sitting there, we're going to go ahead and start cleaning some of these components for the motor. And I'm just using a CRC contact cleaner and a toothbrush. And then we've got the stator. I end up having to move everything because there's so much dirt on that damn stator. I was spraying dirt everywhere. That contact cleaner comes out of that can pretty forcefully, which is good. It's a lot less brushing to do, but yeah. So here we are with those two little panels, and we're just going to buff them. And the on-off switch panel has got some pretty big gouges in it, but I'm not really concerned about it. Looks better in person than it does here on the camera because of the way the lighting is hitting it. You can't really see those gouges as well in person, so no big deal. All right, so we'll go ahead and apply that thermal protection reset panel. And I'm just trying to get the end frame positioned correctly so that it's reading right side up. Now the way this was attached on here, they used drive screws. And so I've got drive screws, and these are a size number 4, and they're 1/4 inch long. I got these from McMaster Car for like $10 a box of 100 or 50 or something like that. I don't even remember now. We just get them started, and then we'll use a brass punch to set them. And there we go. All right, so the stator lead wires on this stator are very brittle. This is actually kind of common in a lot of these motors. They used a fabric as the shielding for these wires, and over time it gets very stiff and they become very brittle, and they easily will break if you bend them, and then you're going to have a short inside the motor somewhere. So messing with these wires on the stator has its issues in itself. If you damage those windings in any way, this motor will no longer function. Also, you may notice that what I'm going to do is I'm going to cut these wires right kind of where they're coming off of the stator, but not where they're attached to the stator. And then I'm replacing them with some silicone sheathed wires of the proper diameter and gauge. And you can get this high temp silicone wire off of Amazon. That's where I got it. But I've used regular wire before, not high temp, but I switched to using high temp kind of early on because that's what all the electricians were recommending. So I'm going to use a butt connector, an unshielded butt connector, to connect these wires. And so you've got a total of 5 wires coming off of this stator, and these are the 2 that are actually on the kind of the top of the stator. And then you've got 3 that are in that more of a 6 o'clock position. Right now they're kind of in a, I don't know, 10 o'clock position, but we'll rotate that stator so that they're at the 6 to work on them. In any case, all we're doing is we cut that wire and then we strip that wire. And again, if you decide to do this, just understand that if you scratch the varnish off of those windings, or you cut those windings or break those windings in any way, your motor will be toast. So I was going to solder them. That's kind of the preferred way to do this, but the solder wasn't cooperating with me, and so I just decided, screw it. We're just going to butt connect them, crimp them, and then put some shielding over them, some heat shrink, or some, heat shrink. I always want to say shrink wrap. Anyways, we've got those crimped, and they're holding pretty good. So it's not like these wires are going to have a lot of force on them or anything. And of course, the windings are, all these wires are wrapped onto the windings with some, basically it's kind of a hemp twine. And so I've got more of that I'm going to fix. We had to cut that wrapping to be able to access these wires. And so we get the shrink tube on there, or the heat shrink, or whatever you want to call it. Then we'll hit it with the heat gun. So the other thing to be cognizant about is the way that these wires are connected to the windings. And I'll point this out in a minute. But basically, they're just soldered onto the end of the winding for each one of these wires. And then there's a cardboard tube that acts as a shield around that. And you don't really want to pull on these wires too much, because if you pull it off of that winding, trying to get anything to solder to the winding is really difficult. So it's right there. That's what that square was. So I guess a professional would choose that point to go ahead and do this replacement of wires, but I'm not a professional, and I'm not messing with the windings down there. So like I said, we got 2 wires here. We'll go ahead and mark this wire so we don't forget where it goes and what it goes to. And then we'll go ahead and do that second wire. So we're going to cut it. And then we're going to strip it. And then we'll go ahead and connect the butt connector or butt terminal. I don't know if you want to get all crazy and yell at me in the comment section about my terminology. That's fine. I'm not an electrician, never claimed to be. But I've done this several times, so I do have an idea of what I'm doing. So then we'll crimp those down. Getting that crimping tool in there is a real pain without abrading on those windings. Probably should have stuck a piece of tape in there or something to better protect it, but I didn't. That would be the safer way to go. But I have another one of these motors, so if I screw this up, I can easily replace it. Somebody had one of these on a drill press, of all things, that I bought. A 3450 RPM motor on a drill press. What were you thinking? All right, so we can go ahead and hit that with the heat gun. And then we're going to add back in that twine and with new twine and connect the old and the new twine together to anchor these wires to the windings. Go ahead and mark that one. We'll just tie these two together. And my replacement twine is considerably stronger and more robust, even though it's thinner than that ancient twine that's on there right now. It's crazy how they made motors back in the day. and they still run today. So we'll just fish that through there. And go ahead and snug it up. Then go ahead and get that other end. Yeah, we're going to need to pull it through. Have something to tie to. Okay. Now I have done this before where I did scratch some of the windings to the point that it removed the varnish off of them. And I revarnished the windings and everything worked out good. But I think I got lucky on that motor rebuild. So as I said, just be careful what you're doing. Try not to damage those windings. And here's where that old twine just snaps. There you go. But we're connected, so we're good. So let's cut that and call it done. All right, so here we are with the other 3 wires. We're basically going to do the exact same thing. So I'm just going to speed up the video here so that we're not talking about this for 2 hours, which is probably pretty close to how long it took me to do all this. Maybe I should play some background music. And I did attempt to do the solder again, but I don't think that solder was making its way inside that butt terminal, so I kind of abandoned the whole solder thing. You can see that cardboard shielding right there that's connected to the yellow wire. I cut pretty close to that. And then we just needed to reapply twine. So at this point, you don't know if you've screwed something up. I guess you could pull out a meter and go ahead and do an ohm check on each one of the wires and verify it that way, but I did not do that. So I won't know if all that is good to go until we attempt to start the motor up. In the meantime, we've got the overload protection klaxon. Clicks on, clacks on. In any case, we're going to go ahead and remove the 2 wires that are soldered on it and then clean it up a little bit and then add new ones. And then mark both of those wires. And then we've got the on-off switch that had some wires soldered to it, so we'll just desolder that. I don't have the most efficient soldering iron, so working with what I got. So this is the switch assembly, and we were able to get the first wire off and a new wire on there, but this second wire, even after I got it off, getting a new one on there wasn't going to work out real well, so I ended up disassembling it. And I don't think that I really showed that on camera because I took it over to a different workbench to disassemble it, but it's not rocket science. There's a pin that goes through it, and just make sure you don't lose the little spring on the inside if you do disassemble it. So here it is disassembled. And so we're attaching that wire. And then we had to drill out that hole a little bit bigger for the wire. And then we'll reassemble. And I think I ended up having to reassemble, disassemble, and reassemble like 2 times because this has to sit under a little foot piece there. But no big deal. So then we've got the capacitor, and both of those wires were soldered on there, and so we need to desolder them and then attach. So rather than solder new wires on there, I'm going to solder little leads that have these blade terminals on them, and that's how we're going to connect this together when we assemble the motor. That way, if we need to pull out the capacitor, it's just an easy unplug. So that is going to wrap up this video. In the next video, we will be assembling the motor. So hope you enjoyed it. If you did, please like and subscribe. If you have any questions, leave them down in the comment section and I'll get to them as soon as I can. As always, I appreciate the support and all of your questions and comments, and I will see you next time.